Okay, welcome back, guys. We are going to be doing some work out of section 9.1 today, which is where we are going to be reviewing some conic section stuff. And I'm going to start you guys easy today with just circles, because you guys have done circles before. You've done all of these before. But circles are by far the easiest. So we're going to start with those today. We'll move into parabolas, ellipses, and hyperbolas in future sections. I know you guys excuse me, all know what a circle is, but let me give you the official conic section definition of a circle. It is defined to be the set of all points x comma y in a plane that are equidistant, which just means the same distance, that are equidistant from a fixed point. That fixed point is going to be the point HK. Sorry, that's bad K. Called the center of the circle. And of course we know then another word here usually associated with circles is the radius. The radius is the distance from the center to a point on the circle. So if I want to draw you guys a quick circle, we know that the center is there at HK, and that would be the radius. Of course, if I extend that distance straight through, then that whole thing is called the diameter. Okay, so that's the basics of what a circle is. Now, moving to our next thing, I'm going to give you the equation. And the standard form of a circle. And this is going to assume that it is with a center at the point HK and a radius equal to r. Then the standard form is parenthesis x minus h squared plus parenthesis y minus k squared equals r squared. So that is our standard form of a circle when we're talking about conic sections. So some of your questions tonight that I'm going to have you do are going to be as easy as this. If I give you the standard form of a circle to be x minus 3 squared plus y plus 1 squared equals 18, and I say what is the center, you should be able to look at that and tell me that the center is the point 3, negative 1. And if I say what is the radius, remember that your radius, this is r squared, so therefore r squared equals 18. R is going to be the square root of 18. And then you do need to reduce that. So that's 9 times 2. So the radius of this circle would be 3 radical 2. And vice versa. You should be able to do that the other way around. If I were to give you the center and the radius, you should be able to come up with that equation. Okay, let's try another example. For this one, let me go back to black here. For this example, the point 1, 4 is on a circle whose center is at -2, -3. Find the standard form of the circle. Okay, so if I've given you the center, remember that your center is your h and k values. So I can go ahead and fill most of this in right away. So I can do x plus 2 squared plus y plus 3 squared equals r squared. So now all I have to do is find the radius. Well, there's a few ways you can do this. You could actually plug in your x and y values and crunch it through that way. Or you can do the distance formula. I'm going to do the distance formula just because I want you to see it again. So the distance formula says I'm going to do the square root, and I'm going to find the distance between my center and a point on the circle. So hopefully you remember your distance formula. That's going to be, let me go back to black here, sorry. You know what, that looks really, really bad. So let's just fix that. All right, so I'm going to do negative 2 minus 1 squared, that's your x2 minus x1, plus y2 negative 3 minus 4 squared, that's your y2 minus y1. We're going to do a little bit of math there. Negative 2 minus 1 is negative 3, squared is 9, negative 3 minus 4 is negative 7, squared is 49, and I find out that the distance between those points is radical 58. So radical 58 is the radius. So then to get my answer, x plus 2 squared plus y plus 3 squared equals r squared. If r is radical 58, square that, you're going to get 58 right there. So that's another question that you guys should be pretty comfortable with. All right, next one. What if I give you what's called the polynomial form of a circle? X squared minus 6x plus y squared minus 2y plus 6 equals 0. And I'm going to say find the standard form of the circle. Now, this is going to take us back to something that we did earlier on. If you go back and look in your notes for section 2.1, you'll see more examples of this. What I've got to do here is complete the square on both of my variables. I've got to complete the square on x and complete the square on y. This 6 means nothing to me yet, so I'm going to wind up taking that over to the other side. So let me give you a quick review here of how to do complete the square. X squared minus 6x, leave some space, plus y squared minus 2y, leave some space. That positive 6 is going to go over to the other side as negative 6. Now, when you complete the square, you need to make sure that the coefficient of your squared terms is 1. In this case, it is, so I'm ready to find the magic number. To find the magic number, you focus on these values right there. So let's do the x's first. What's half of negative 6? That's negative 3. You square that, plus 9. Oh, but since I just added 9 here, I've got to add 9 to the other side so that I stay in balance. Now let's also complete the square on y. Look at your negative 2 number in blue there. What's half of that? That's negative 1. Square that, that's plus 1. Oh, then I've got to add 1 to my other side to stay in balance. Now the whole point of doing that is that now this can be factored as a perfect square. That's going to factor to x minus 3 squared. Do the same thing with your y. That can be factored as a perfect square, so that's going to be plus y minus 1 squared equals, and combine your terms on the other side, negative 6 plus 9 is 3, plus 1 is 4, and that is my standard form of the circle. So now that I have the standard form, I could now easily say what's the center, what's the radius, and you should be able to tell me that your center is the 0.31 and your radius is 2. Okay? All right, regular pre-calc, you guys can stop. Your notes are done. Honors pre-calc, I've got one more question to show you guys. All right, so let me give you a circle in standard form. X minus 4 squared plus y minus 2 squared equals 16. What I'm going to ask you to do here is to find me the x and y intercepts of that circle. Okay, so let's start with the x-intercepts. Going back a few units, we know that for any function, in order to find my x-intercepts, I want to plug 0 in for y. So x-intercepts, plug 0 in for y. So let's do that here. That would be x minus 4 squared plus 0 minus 2 squared equals 16. Okay, well that's x minus 4 squared. I can't really simplify that, but this one I can simplify. 0 minus 2 is negative 2. Negative 2 squared is 4. So I get to here. And now I'm just going to solve this by undoing. So let's move the 4 over. That would be x minus 4 squared equals 12. And now get rid of your square. That's going to be x minus 4 equals plus or minus, don't forget that, square root of 12. But that reduces, so that's really plus or minus 2 radical 3. And then move your 4 over. X is going to equal 4 plus or minus 2 radical 3. Those are both of my x-intercepts for that circle. And notice those are exact answers. Your calculator would not give you those. So now let's go ahead and find the y-intercepts in a very similar fashion. To find the y-intercepts, you're going to plug 0 in for your x. So that's going to look like 0 minus 4 squared plus y minus 2 squared equals 16. So let's go through and simplify this in a very similar manner. So 0 minus 4 is negative 4 squared is 16, plus your y minus 2 squared equals 16. Now we're going to solve by undoing. Let's move that 16 over. That's going to give me y minus 2 squared equals 0. Square root both sides. Y minus 2 equals plus or minus the square root of 0, which is just 0, so I don't have to worry about plus or minus. And here I get y equals 2. So this one has 2 x-intercepts, but only 1 y-intercept. Okay, so that's what you guys are going to be dealing with on the homework for this section, and I will see you next time.